Hello there. In today's presentation, we'll be discussing the Merton model. In the world of finance, a common financial instrument people utilize so as to achieve monetary gains is a derivative. Derivatives, which should not be confused with rate of change, are financial contracts set between two or more parties whose value is dependent on an underlying asset. Common underliers include stocks, commodities, currencies, bonds, market indexes, and interest rates, which we'll be tapping onto for this presentation. Interest rate derivatives, also known as IRDs, are derivatives whose value is directly correlated with either a singular interest rate or a group of interest rates. The understanding of an interest rate's value could be seen as complex, given that it is factored in by multiple influences, some examples being economic state, human interventions, and political matters. Because of this, one of the instruments used by traders and concerned parties to narrow down on an interest rates movement over time is called a short rate model. Short rate models are mathematical models used to assess an IRD's value through the term structure of its interest rates, which is done through describing its short rate's evolution over time, denoted by R of t. That's why it's called a short rate model. Short rate is the geometric average of a derivative spot rates over time. In other words, it's the instantaneous spot rate, where the spot rate of an interest rate describes its immediate value. A widely used short rate model is the Merton model. Named after its founder, Robert C. Merton, the Merton model was developed in 1974. It is a structural model that describes a company's credit risk, which provides a clearer picture on how well a company is doing in taking care of its debts and other financial obligations, through a direct relationship between the probability of the company's credit default and its equity. Credit default is when a debtor fails to pay its financial obligations to a creditor. A radical scenario that occurs from this event is when the concerned company files for bankruptcy, which often leads to its ceasing operations and thus negative monetary results for its investors and security holders. Now we go on to the definitions. Equity, which is also known as shareholders' equity, describes the monetary value provided to a company's shareholders, which is dependent on the combination of liquidated assets and processed debts and other liabilities, which is shown in the equation here. The said variables are shown in a company's balance sheet. However, the value of a company's assets and liabilities are unobservable. In contrast, the equity is shown through the product of a market share price and the number of currently owned shares. Consider the scenario at time t, where the assets has less value than that of your liabilities, which equates to your equity being less than zero. This implies that shareholders do not achieve monetary gains from owning shares of the concerned company, which prohibits them from purchasing additional shares or giving further capital to the company. Alternatively, shareholders will sell their shares and cease in financially supporting the company, which could possibly lead to the company's credit default. Another definition that we'll be using for the formula is your log normal distribution. This is a continuous probability distribution in which the logarithm of a random variable is normally distributed. This implies that if a random variable x has a log normal distribution, y is equal to ln of x is normally distributed. For the formula, we assume that the logarithm of the value of a company's assets follow a normal distribution. So, the Merton model's formula is shown in this equation, where a sub t is the value of a company's assets at time t, n is the cumulative standard normal distribution, L is the value of the company's liabilities, R is the risk-free interest rate, and T is the maturity period. Furthermore, D sub 1 and D sub 2 are given by the following equations. So there are certain assumptions that are being followed for the Merton model, which include R and volatility of stocks value are constant, distribution of shares remain constant and unchanged, execution of IRD contract is at maturity date, and no dividends are paid out until maturity date. Now, these assumptions are essential in utilizing the discussed formula for the structural model. And there are two general approaches in utilizing the Merton model.
Now we will talk about the first of the two general approaches, which is the Merton approach. This approach uses single point calibration and requires values for the equity, liability, and equity volatility. This approach solves for the values of assets and its respective volatility using a set of two nonlinear equations. The first equation is the option pricing formula, which is given by the equation below. Here we have P of small t capital T is equal to e raised to negative r delta t. The second equation relates the asset volatility to the given equity volatility, as shown in the equation below. Here we have n times d sub 1 is equal to the partial derivative of e all over the partial derivative of a. Given that the value of equity is available and the equity volatility can be estimated, these two equations can be used to obtain an estimate of the value of assets and its respective volatility. However, equity gives information on default only when it is near zero. Otherwise, it is not enough to provide reliable credit information using this approach.
We have another approach called the time series approach. This utilizes a time series from the name itself and links equity and other mentioned variables in time order. It sets up a system of nonlinear equations solving for a time series of asset values for time periods t equals to 1 until n, as seen below in the following equations. Now, this time series describes the annual standard deviation of asset returns, denoted by the variable over here. This value captures the volatility of assets from t is equal to 1 to t is equal to n. The distance to default, or denoted by dd, is the distance between expected value of the company's total assets to the point of credit default. And the default probability, which is denoted by PD, describes the probability of the asset value being less than the liability threshold at maturity date t. Once the values of A and sigma sub A are attained, one could solve for DD and PD at each time period given by the following equations.
Here we have the advantages of the Merton model. The main advantage of the Merton model is its simplicity and intuitive method. The intuition of making a company's equity a call option on its assets allows the use of option pricing methods to estimate the default. Hence, the Merton model allows an efficient approach in estimating credit risk and calculating the equity and debt values. However, the application of structural models is unrealistic. For example, the Merton model assumes that a company has a single issue of zero coupon debt. Also, the model only recognizes the firm's default at the maturity of the debt. The asset values of the firm before maturity are not considered in the assessment of the credit risk. For example, the value of a company drops below the level of debt, even though it is able to recover and make the payment of debt prior to maturity. It is ignored in the Merton model. It is incorrect to assume that the firm value is tradable, since the company's value and its parameters are not observed directly. In the Merton model, it is difficult to estimate the value of a company's assets and their volatility since they are not observable in the market, such as the company's equity. Also, calculating stochastic interest rates is sometimes more difficult than assumed. And lastly, for very short maturities, it is hard to fit non-zero spreads since the Merton model has no short-term credit spreads. Consider a company with assets equivalent to $1,000 with stock price volatility of 25%. The company's expected return of assets is 20% and its liabilities are worth $600. Find the distance to default and the default probability at t equals 1. For the solution, we first calculate the distance to default, which is given by the equation below. We substitute the values to get 2.718 or 2.72. Now, using the value obtained in 1, the default probability is given by 1 minus n times the distance default, which is equal to 1 minus n times 2.72 or 0.33%. For the second one, assume that the firm's assets are worth $100 with a volatility of 25% and liabilities worth $90. The risk-free interest rate is 10%. Calculate the value of a call option at t equals 0.5. For the solution, first we find the value of d sub 1, which is given by this equation. And we substitute the values to get 0.9672. Now, using the value obtained in 3, d sub 2 is given by d sub 1 minus the asset volatility times the square root of delta t, which is equal to 0.96782 minus 0.25 times the square root of 0.5, which is equal to 0.7904. And finally, using the values of d1 and d sub 2, we have this equation for the equity. And we substitute the values, we will get 16.70. And hence, the value of a call option at t is equal to 0.5 is $16.17.